Hello class, I'm coming back with section 5.4, application of fundamental theorems of calculus part 2. The fundamental of calculus part 2 provides a very powerful method for evaluating the definite integral of a function. Assuming that we can find an antiderivative of the function, in this session we apply the fundamental theorem of calculus 2, part 2 to science and engineering problems. And so we can regard an indefinite integral as representing an entire family of function. So one entire derivative for each value of the constant c. Okay, so now here is a table. One is for linear properties of integrals. Let me label it. Okay. So here you can see that I have integral of fx of c times fx dx from a to b, which will be just c times integral from a to b of fx dx. So in here I can move out the c outside of the integral. And next to it is the integral of fx plus g of x dx. From a to b, I can split it out, become two integral. One is for fx and one for g of x. Okay, so and down here is table of antiderivatives that we have learned in previous section. So yeah, so keep in mind that. Yeah. Okay, so these are the important ones. So you may have to write down, and I usually gonna say we usually gonna use this one, what else? Maybe this one also. Because we regularly see you're gonna see it. For the rest down here, maybe this one also. For the rest down there, sometimes you can see it, but that's the reason why you need to write down before taking the exam. Okay, maybe this one also. All right. Okay, now let's move down and see that in here, when a formula for general antiderivative is given, it is valid only on an interval of continuity. So the applications down here, first is physics, engineering applications. Okay, which is our main focus for this semester. So suppose a particle P moves along a line. Okay, so let me use another. What happened? Yeah. Okay. So let's say P is at t equals 0. P is maybe at here, -1. Okay. And then at t equal to 1, P is at 0. And then t equal to 2, P is at 3. And recall, this can be represented by a function You can let st be the position of a particle at time t. Okay, and so the instantaneous velocities of these particles is a derivative, which is s derivative of t will be equal to v to t. So remember that's v uh, v stand for velocity, right? And the acceleration of this particle is the derivative of the velocity. So this one is okay. Okay. So, all right. So we mean it is the second derivative of the position. So at will be equal to v derivative t, which also going to be equal to second derivative of st. Okay. So let's we do example number 13. So we have st equal to we suppose the particle has position function as st equal to t squared minus 1, right? And then let's plot position and velocity as function of time. So let me draw it. Come on, not straight. Yeah, this one. So here is the position, which is s, and we have time is here, which is t. Okay. Okay. And it was start from 1, right? Negative 1. So start from negative 1. So this at this point it was 0, negative 1. And then it's moved to 1, 0. Right? 1, 0. Yeah, you need to use either color. Okay, so 1 point, 1 point. And the last one is 2 and 3, right? 2 and 3. So 2 here, 1, 2. Oh, so too far. And then 3 here. Okay. So I use other color. Oh, come on, man. Okay, so red one. Here. And then I will just connect it. Okay. And this is 2, 3. Okay, so now, so I have this function as st equal to t squared minus 1. Okay. So we also want to have the function of the velocity also, right? So we want to find the velocity also. So the velocity is when you take the derivative of that, t will be s derivative of t, and that's going to be 2t. So then Let's do it. Oh, all right. Okay, so we have 1, 2, 3, 4, and then here's 1, 2, 3. So we have 1 and 2 here. This is time. This time start with T. Let's stand by T. And then V here. It is S derivative T, right? So that's gonna be 2T, right? So it's go to the origin, and then the second one can be 1 and 2. Here we go. 2 and 4. Here we go. So I have 1 comma 2, 2 comma 4, right? Then just connect all this point. Make a line. Okay. You're good. All right. So I have finished plotting the position and velocity as a function of time. Okay, so now we're gonna plot the acceleration as a function of time. So remember that a of t, use the article now. So you can see up here a of t equal to v derivative t and equal to the second derivative t. So you write as a of t will be v derivative t, and also going to be second derivative of t, s, and s will be equal to 2. Okay. So maybe I have another. Okay. It is s second derivative t, which is 80, and it is t. So 1, 2. So this is just a function. It's just 2, right? So it is a horizontal line go to y equal to 2. So okay. All right. So and C, and you can see if, or maybe I have to use the other color. Okay. All right, better. So as you can see in here, for the position, you can take the derivative to get the velocity. And then from velocity you take one more derivative to get acceleration. So then okay, so I have st here and first derivative t and s second derivative t. Okay, and in inverse way, s second derivative, the acceleration is the antiderivative of velocity, and velocity is antiderivative of the position. Okay. So let's go down. We're gonna integrating these quantities leads to firstly displacement, which is integrating the velocity leads to um, the integral vt from t1 to t2 will be equal to the integral of the s derivative t dt from t1 to t2, we're going to be equal to st2 minus st1. Okay. So this gives the net change of the position or displacement of the particle during the time periods from t1 to t2. So remember that we know that s ft is the antiderivative of vt. Okay, the position is antiderivative of the velocity. So that's the reason why we're just gonna apply the fundamental theorems. You got like st2 minus st1, right? Okay. And then the left chain in velocity will be the integrating the acceleration. So um, so integrate t from t1 to t2 will be equal to integrating of the vdv of t dt, right? And that's according to the fundamental theorems. You're going to get vt2 minus vt1. And that's give you the net change in velocity from t1 to t2. And finally, we learn we have total distance traveled. We is in you want to integrating the absolute value of the velocity, which is t1 t2, which is integral absolute value of vt dt from t1 to t2 equal to integral absolute value of s t dt from t1 to t2. And that gives the total amount of the distance traveled by the object from t1 to t2. Okay. So, okay. So now, let's we do example 14. A particle moves a long line so that its velocity at time t is vt equal to 3t minus 7. Okay, so this we in it as a meter per second, and part A, we're gonna find a displacement from t equal to 1 to t equal to 4, and B, we're gonna find the total distance traveled from t equal to 1 to t equal to 4, and part C, we're gonna find the acceleration of the particle as a function of time. So that means what? That means we're gonna find a t equal to question mark, right? Okay, let's start with part A. Part A, we find the displacement from t equal to 1 to t equal to 4, right? So that means what? That means we take the integral from 1 to 4 of vt dt, right? We equal to integral from 1 to 4 of 3t minus 7 dt. But remember that. Remember that for this one, you actually can split it become two integral. Okay, and make it become like 1 4 3t et minus integral from 1 to 4 7 dt, right? Okay, so from here you can apply the fundamental theorem calculus for 2 to handle for each interval over here. For each interval over here. So the first one, you know that it's going to be 3t to power 1 plus 1, which is 2, divided by 2, right? And then you're gonna plus. Sorry. You have to have substitution for t equals to 4 minus for t equals to 1 over here. And you're gonna minus for the second integral, which is 7, and you're gonna time with t, right? Because 7 in here is constant, so it's just gonna time with t, and that's gonna be from 4 to 1. Okay, now let's go to here. Substitute for the first one. I have 3 square and I become 4 square. I actually can move out number 2 here, right? And then I minus for 1 square. Okay, I just gonna substitute t square only, 4 square and minus 1 square. See that? And then a minus 4, 7 times 4 minus 1. Okay. Okay, so now that's gonna give me as 3/2 times 16 minus 1 is 15, and minus 4 7 3, and then use calculator. You're gonna get let's see. You're gonna get 3/2 as a answer. Okay, so let me circle this with the red color for part A. Okay. Let's go to part B. Part B say we're gonna find the total distance travel, right? Total distance travel, which is here, right? You're gonna try to use the antiderivative of the absolute value of the velocity, right? So for still, you do the integral from 1 to 4 of the absolute value of Vt dt, and that's going to be 1 to 4 again, absolute value of 3t minus 7, oops, dt. So in this case, you need to for this one, you need to draw the graph to see what happened. Okay. So let me draw the map. So for 3t minus 7, for the s 3t minus 7, in order to find the t intercept, you need to I need to make s equal to 0. So we have t equal to 7 over third, right? So I have 7 over third at the 1, 2, 3. I have 7 over third around here, and then -7 is the, so -7. Maybe have to that. So 1, 2, 3, 4, 5, 6, no, 7. Oh, 0 here. Okay, so let's say -7 is the -7 is y-intercept, and x-intercept gonna be 7 over third, right? So I draw the line through these 2 points, but I know that the function we just consider from 1 to 4, right? So at 1, so I can have like t here, s here. At 1, I have s become 3 minus 7 is -4. So -4 is around here. Okay, so put -4. And at say at 2, at 2 I have -1. At 2, -1. And then at 7 over 3, s will be 0. So, and let's go up to 4. So I will have 1, 2, 3, 4. Say 4 here. Then have one more is 4. 4 to 3 is 12. 12 minus 7 equal to 5. So because this one is a little bit far, so I'm gonna just don't need it. Maybe go up a little bit more. Let's see. So 1. 1, 2, 3, 4, and 5 up here. So 5 is around up here, right? So I will draw the line from here, go through here to this point. Just keep going up. To here. And they stop at there. Okay. So you can see that the line, if you take the integral, right, you take the integral from 1 to 4, you can see that from 1 to 7 over 3 will be negative. So from here to here is negative. Okay, and then after that I have from 7 over third 7 third to 4 will be positive. Okay, so if we want to take the you want to take the derivative of a absolute value like this, what you do is you will have to take the one from 7 over third first to 4, 3t minus 7 dt, and you minus 4 the negative 1, which is from 1 to 7 over third up 3t minus 7 dt. Why? Because this one is positive area, and this one is the negative area, right? You see that? And when you take, the integral of an absolute value, you will have to, consider about this, and that will be equal to, let's see, I have enough. I don't have enough space. Then you have so then you have, so I will just clean this up in order to get more space. So this is going to be 7 over third, and this will be 1. Okay. And I'm gonna have equal to, so 3t now can become 3t square over 2 and minus 7t. Okay, at this time I can just do like this instead of like before, right? Because I know how to do already. So you can do all of this at the same time, from 7 over third to 4 and minus 4 3t minus 7 from 1 to 7 over third, and that can be equal to that can be equal to negative okay, so let me So I have 3 times 4 square over 2 minus 7 times 4. Okay, so this is for substitute 4. And then I minus for this really not enough space, so I will have to come on, I will have to move it down here and write as 3 times 4 square over 2 minus 7 times 4. That is for the substitute 4. And minus for the 3 times 7 third square over 2. And then don't forget the parentheses. Minus for 7 times 7 over third. And then you will have to minus for big parentheses with 3 7 over third. So, I should have 7 t squared. Okay. So I change this a little bit. So I have 3 times 7 over third square over 2 minus 7, and then minus for 3 times 1 square over 2 minus 7 when you substitute 1 into it. Don't forget the parentheses for each time you substitute. This is gonna be a little bit crazy if you don't follow that. Okay, so now if you use a calculator, okay, so let's use calculator for this one. This one a little bit crazy, so I will show you how I use calculator. Great. Okay, so I have parentheses 3 times 4 square divided by 2, and then minus 7 times 4, right? Close parentheses, and then minus for 3 times parentheses. Oh, I had to have the parentheses before the system 3. So put parentheses 3 times parentheses 7 divided by 3, close parentheses, square, and then divided by 2. Oops. And then minus 7 times 7 divided by 3. And then close parentheses. And now I'm gonna minus for a big parentheses, and inside another parentheses, I need to have 3 times 3 times 8 parentheses, 7 divided by 3, close parentheses, and then square. Well, actually, I can use this square quicker. and then divided by 2, and then minus 7, close one parenthesis, and then minus for 3. 3 times 1 is 3, so divided by 2, and then minus for 7, and then close a small parenthesis and close big parenthesis for that, and enter. Oh, come on, something wrong. Something was wrong. Let me do again. So 3 parentheses. So 3 times 4 square divided by 2 minus 7 times 4. Close one parenthesis and minus. Okay, parenthesis. 3 times 7 divided by 3. Up 3. Close parenthesis and square divided by 2. And then minus 7 times 7 divided by 3. Close parenthesis. And then minus open parenthesis, open small one, 3 divided by 7. No, 3 times parenthesis 7 over 3 square divided by 2 minus 7. Oh, I forgot the T. That's the reason why. Okay. I should have another 7. So another T here. And then here for this one, it's going to be 7 and then, okay. Let me fix this. So I have minus 4, 7 times with 7 over third. Close parenthesis. Out. So I have 7 minus 7. Okay, so I have minus 7 times 7 divided by 3. Okay, and co-parentheses. All right, minus 4, 3. No, let parentheses first. 3 divided by 2 minus 7. Okay, so another 1, but just it. Close parentheses and go one more time. That should be okay. Okay, so I got negative 22.16. This should be, that is not a correct answer. Something I make a mistake. Let me check. Okay, so I think we should not do too many things at the same time. That's so complicated. We're just gonna do one more step. So let's see for this one, what is it gonna be? And put that here, right? So I have 3 times 4 square divided by 2 and then minus for 7 times 4. And that's going to be equal to -4. So put -4 down here. Okay. And then minus 4. The next group maybe more complicated. So I have 3 divided by 2, or actually I can write like this: 3 times 7 divided by 3 square and divided by 2, and then minus 4 7 times 7 divided by 3. And, oh, okay, that's it. After I have negative 8.1 something, so make it become fraction. So I put my one. So I have negative 49.6. I have negative 49 over 6. And then I minus 4. Minus 4. Next one. This one is as negative 49 over 6 again, because the same as here. So, and then I have minus 4. The last one is the last one is 3. Oops. 3 divided by 2 minus 7, and if I convert it to be fraction, it's going to be negative 11 over 2. So negative 11 over 2. Okay. So now maybe I now can use calculator. I have negative 4 minus 4 parentheses a negative 49 divided by 6 close parentheses, and then minus 4 a big parentheses and another parentheses with a negative 49 divided by 6 close parentheses, and I have minus for a negative 11 divided by 2 close parentheses, and then enter. So now it's good. Now I have 6.823. Yeah, so it looks like sometimes if you use the calculator with so many things, that could be not a good number. Why I show that at the answer before is not correct, because it gives me a negative number, but that doesn't make sense for a for a total distance travels, which has to be a positive number. Okay, so now the answer is 6.8333. And for part C, I'm gonna just put it up here, right? C, we find the acceleration of the particle as a function of time. So I'm gonna say it's AT, and that's gonna be equal to V dv of t, and that's gonna be equal to 3 as the answer. Okay. So we done with example number 14. Let's move down and try to do example 15. So particle moves along lines so that its velocity at time t is vt equal to t squared minus g minus 6 meters per second. And A, we're going to find the displacement of the particle during the time periods from 1 to 4 from previous page. Okay, so for the displacement, we just we're just gonna go ahead and do this one. Do the integral by apply Vt. Let me change this. Substitute. So T1, T2. Substitute Vt as T squared minus T minus 6, right? dt. Okay. And now I can, convert it to be as derivative of t, which is the antiderivative of Vt. So now I have antiderivative of t squared can be divided as 1/3 t to power third. Okay, and then for t, I have minus t going to be t squared divided by 2, right? Next one gonna be negative 6 times t. So that will be the antiderivative of Vt, and then the interval is in between T1 and T2. Remember that T1, T2 in here is 1/4. So let me change this one T1 in here and T2 in here. So 1 and 4. All right, here is 1 and 4. 1 and 4. And now I will substitute 4 first. And I have 1/3 times 4 to power third minus 4 square over 2. I'm going to have a parenthesis first, right? Minus 6 times 4. Close parenthesis. And then I minus 4 a parenthesis. Now I substitute 1 into it, right? So I have 1/3 times 1 cube minus 1 square over 2 minus 6 times 1. And we're gonna close parentheses. Okay. So now let's simplify it. So so you know that this one gonna be 64 divided by 3 minus 16 divided by 2 gonna be 8 minus 24, right? And the second one will be minus 4 a negative 37 divided by 6. You use a calculator. And finally you will get negative 4.5 if you use a calculator. Okay. So now, okay, back up here. Let's move to part B. We find the distance traveled during this time periods. So again, the total distance traveled is the integral of absolute value of the function. So 1/4 Vt dt absolutely, and that will be equal to 1 to 4 again, an absolute value of t squared minus t minus 6, and then dt. Okay, so at this time, instead of graphing, right, I will show you another way for you to figure out when it's become to figure out the when it's become positive and when it become negative, right? So I can convert the t squared minus t minus 6 become a fraction, sorry, factor, two factor as t minus 3 times t minus 2, not plus 2, so, right? So if I set to this equal to 0, right? If I set to this equal to 0, uh, so this give me t equal to 3, and this one gonna be equal to 0. So if t minus 3, so let's say let's say equal to 0, and that make t equal to 3 or t equal to -2. Okay. So from here, I will have like a side table for down here a little bit, right? I'm gonna have side table for t, and the second column gonna be at negative infinity, and here is at -2, here is 3, here is positive infinity. Right? Okay, so the second row is t minus 3 and t minus 2, and you know that two z factor multiply each other will be v of t, right? So okay, so we determine the sign of each factor. So then from there we're gonna determine the sign of the vt, right? So we know that at t equal to at t equal to -2, we have t plus 2 is 0 and vt equals 0. And at t equal to 3, we have t minus 3 equals 0, and then vt going to be 0. Okay, so now we have three intervals to consider, right? So from -52 to -2, I'm gonna choose a number. Let's say negative. Let me use the other color. Let's say -3, and then here is 0, and here is 4, right? And then substitute for each interval, for each factor. Let's see. So if -3 minus 3 going to be a negative number, right? -3 plus 2 going to be a -1, so negative again. So two these factors multiply each other will be positive. So VT become a positive. Okay. And now at 0, I have t 0 minus 3 is negative. 0 plus 2 will be positive, and then negative times positive will be a negative. Okay. So from at 4, we have a 4 minus 3 is positive, and then I have positive here. Okay, so we consider we have to consider the interval from 1 to 4, right? 1 to 4. So we know that 1 was somewhere over somewhere in this interval. So basically, let me gonna have 1 here. Right? We don't. Oh, sorry. 1 is after 0. So 1 is after 0. So here's 1, right? So negative here, positive here. So we don't have to consider all of them, but we know that from 1 to 3 is going to be a negative. From 3 to 4 will be positive. Okay. I don't even have to worry about, right one here. So that make not nice in here. So just, gonna write as like this. So I have here is negative, positive, and a negative. So negative, positive, right? We know that we'll consider about here it is double, negative, and the double is positive. So we're gonna say from the interval from 1 to interval from 1 to 3, not inclusive for 3, will be negative, and the interval from negative 50. The interval from 3 to 4 equals it will be positive. VT. Okay, so now let's come back with this. I'm gonna split it, become 2 interval. The first interval gonna be taking the positive one, so have 3 to 4 first. 3 to 4 t squared minus t minus 6 dt. Okay, and then a minus for a negative, vt. So you're gonna have from 1 to 3 t squared minus t minus 6 dt, because this is positive and this is negative interval. So that's the reason why I want to minus it. So now I will have equal to t cubed over 3 minus t squared over 2 minus 6t. Everything for this, you will substitute for 4 and 3, and then a minus for same one as 3 cubed over 3 minus t squared over 2 minus 6t, and from 1 to 3. Okay, so now substitute time. So we have 4 cubed over 3 minus 4 square over 2 minus 6 times 4. Okay, so I have currency here, and then the minus 4 substitute 3, right? So 3 cube over 3 minus 3 square over 2 minus 6 times 3. Okay, done with the first integral. And then minus for the second one, I have t, no, not t anymore. So we have 3 to power third over 3 minus 3 square over 2 minus 6 times 3. And then close parentheses minus 4 a parentheses 1 cube over third minus 1 square over 2 minus 6 times 1. Okay, one more step. I know that this one will be negative 32 over third. Okay. And then I have this gonna be negative 27 over 2. So I'm done with this. And then a minus for open parentheses. Maybe I open over here. I have this as negative 27 over 2. And then minus 4, the last one going to be negative 37 over 6. Excuse me. And then equal to 61 over 6. That's the answer. Okay. So, let me move up a little bit. Now we're going to find the acceleration as a function of time. Yes, acceleration as a function of time. So that's going to be just a t, right? With e equal to the v dv of t. And that's going to be equal to 2t minus 1, easily. Right? I will let you guys to try number 16. Answer in here going to be 2/3. You try for the part A. B going to be answer equal to 4. C is just, trying the best. And now we move to example 16. Okay, example 16 say, the following figures show the power consumption in San Francisco for a day in September. P is measured in megawatt, and T is measured in hours started at midnight. Okay, so you can see, okay, you can see that the graph is down here. So we have power is the rate of change of energy. Oh, okay. So one more thing that you have to consider is power is a rate of change of energy. So that means PT will be the EDU of T. So then in 24 hours periods, you have PT from 0 to 24, right? Gonna be equal to the integral from 0 to 24 of e to e to the E derivative of ET. And by fundamental theorem, you're going to have E24 minus E0, which is the total energies used on that day. Okay, so now our goal is to estimate the energies used on that day. Remember that we estimate right now, right? However, we do not have the function of E, right? But we do have the graph of P. And we will estimate the interval using 12 intervals. So here the T is 2, right? And using the midpoint as our sample point. Okay, so if you use the midpoint, okay, so integral from 0 to 24 pt dt, okay, we are estimating energy, right? Can be estimated as delta t time with p. Okay, so because we use a midpoint, right? Midpoint. So 0 to I mean midpoint. So we use delta equal to 2, right? So midpoint 0 to 2 when we midpoint of that will be number 1. So P1, and then plus with P of 3, and plus with P of 5, and then I have this one, and then keep going on until I plus with P of 25, because we have until oh wait, 23rd, sorry. We have only 24 hours, right? Okay, so we have the T was let's approximate 2 time with 440, right? P1 is 440. So if you want to check, P1 was 440. Remember that I just estimate. So in here it's about like 440. So and then I add with at 3, the power is 400. So 400, and then I add with 5 is as 5 is I'll say 420, and then I add with, so the next one is P7. So this one is here, about 620. 620. Okay, so and it's keep going on, right? Keep going on. So I'm gonna just move to the next point over here. So this one goes here, here, here. That was no, it's just, I think it's 790. So 790, and then this one, and then here, and then here. here, here, here. So I'm just gonna put all them in 790 and then plus with next one is 840 plus 850 plus with 840 again and plus with 810 690. It's going down, right? And then 670 and 550. So I will have 15,840 to get it. So 15,840 at the estimate. So I'm gonna say energy. Oh wait, energy used is about 1,500, 15,840 megawatt per hour. Is that right? Okay, yeah. So um, so that's gonna be the answer. Um, so we have finished this section, and I will come back with the next part, next session. See you guys later.